let's start with chapter 3. I'm now recording and I want to get the camera on. All right, so chapter 3, I need to switch to speaker view and put me on speaker view. Chapter 3, what do we have? We have, I had it set up right. Somebody moved. Chapter 3, decision statements. Yes, I am the one that was supposed to have code listings due today for chapter 3 because that does help you coming into the class. And I accidentally made it for Wednesday, originally thinking the test would be today and we would be starting chapter 3. So with the switch, we don't have them done. So we'll go along here. I would recommend you have your book available for some notes. But chapter 3 talks about something called decision statements. Up to this point, we've been working with our programs and we've been going sequential. Line 9 to line 10 to line 11 to line 12 to line 13. But as we go through, you're going to see there's going to be situations where I don't necessarily want to do certain blocks. I only want to do certain lines or certain blocks of code if something particular occurs. And the way we do this is with something called an if statement. Some old languages used to have ifs and thens and elses. We don't have the thens, but we have just an if. So first thing I want you to do is take a look at, how does this process work? Well, the first thing we're looking at is something called single alternative. And I have a copy of a flow chart, a short one in front of you. And as you can see, we start at the top with an arrow and come down and come into a diamond, okay? Now, if we were going old school, we would be writing up code in possibly a flow chart or something called pseudocode. But it's ways to prep what we're going to do before we actually start doing. And we're going to do that in a program today. If I take a look at this diamond, coming out of the diamond on the right is an arrow that says true and goes to a rectangle, which in the old days, this is where we would put a line or multiple lines. Coming out of that block, we come down and make a left and go back right into the arrow coming out of the bottom of the diamond. So an example of what the syntax might look like is if now to the right here, I have a set of parentheses. And inside of that set of parentheses is going to be a Boolean statement. Now, Boolean is a statement that results in either a true or false. In this case, I say if parentheses average is, now this thing here greater than or equal to 90. That's going to result in a Boolean, a true or false. And if it's true, I do the next line, which says system.out.println, typo, println A, okay? You notice that if it's false, I would be skipping that line, system.out.println. But if it's true, I do the next line. Now you can see I have a note in red at the end of the line that at the end of my if statement, if average is greater than or equal to 90, I do not want a semicolon, because then it thinks it's at the end of that statement. And some of you will actually put a semicolon there and not understand why this is or isn't happening in the next line of code. Okay? So if a Boolean statement, now this greater than or equal symbol is one of our operators, and rolling down to the bottom of my page, I talk about the 6 relational operators. So for test number 2, not this Wednesday, for test number 2, right there is 8 points. What are the relational operators and what do they do? The relational operators are less than, greater than, less than or equal to, greater than or equal to, equal to. You notice the equal to is a double equals. Why? Well, because the regular equals already used up. The regular equals is our assignment operator. So in order to do equals, we need the double equals. And then finally, the exclamation stands for not. So that would be not equal. right? And how do relational operators work? Here's 2 points. They compare expressions. Now remember, in your math world, what an expression is. 2x plus 3 is an expression. 2x plus 3 equals y is an equation. So when I say compare expressions, it's going to be similar to an equation, no equal sign. Compares expressions, the result Boolean. Well, what are examples of expressions? 3 is an expression. Boom, done. X is an expression. Even though it's just a variable, it's done. It's an expression. Y plus 6, it's an expression. So examples here, X less than 3, Y plus 6 equal 11. Each one of these is going to result in a Boolean giving me true or false. Okay, so the second one we're going to take a look at is called the double alternative. And it varies slightly from the single alternative because if I come down into the diamond. If I make a right and come down, I follow the true path. But if I come straight down out of the diamond, again, I follow the false path. But this time I have a rectangle there to do something. So if it's true, I do something. If it's false, I do something. And then both rectangles come down and join back into a single path in my program. An example of a double alternative. If average is greater than or equal to 70, system.out.println, you are passing. Now, the false part is my else. And coming out of this else, I want to make a block of code. So how do I represent a block? I have a left brace, my lines of code. Hey, system.out.println, you are failing. System.out.println, get help. System.out.println, your mom's going to call you stupid. Yeah, I don't know, whatever. And then another brace so that I make sure I do that entire block. I could have had a block up with the if I wanted. I could have the block wherever I wanted. But this time it's a double alternative. The average is greater than or equal to 70, else. So I have 2 different paths to go. Questions? So far, so good.
All good.
The classic example for a double alternative is getting somebody's pay, calculating their pay. You all have a pretty good idea of what you make an hour and how many hours you work and what your paycheck's supposed to look like. But some of you also know if you work overtime, you should be getting time and a half. All right, so I'm going to write down what's called pseudocode to figure this out. Because once I have the pseudocode figured out, it's really easy to go type the program. And programming is supposed to be typing, not so much doing the work right there. So I'm going to get ready and I'm going to say, okay, the first thing I need to do is I need to input. And what's something that I would need to input to do this calculation of pay?
You want to get the hourly pay rate.
Okay, so let's do HR, capital P-A-Y, capital A-R-T. Okay, I'm just thinking ahead of time before I even go to my computer and start typing. I'm going to yell at my 3rd semester students tomorrow because I know they didn't do any thinking ahead of time because they weren't even close with their programs. In fact, only 7 out of 12 turned them in. So they're in big trouble. So I need to know how much I'm making an hour. What's the other thing I need to know?
How many hours you work a week?
Right. Why don't we go with something called num hours? And again, I'm using camel case. And as you're looking at this, you're going, yeah, looks pretty good. All right. So now I need to ask myself a question. And what would that question be?
What are you going to need to make that happen?
Yeah. Do I need to calculate overtime or not? All right. So I'm going to start with an if statement. If. And I need some kind of what we're going to call Boolean expression. I need to come up with a true or false. So how do you know if you're going to get overtime or not?
You work more than 40, so hours is greater than 40.
Right. We're going to go if num hours is greater than 40. If it is, I know I need to calculate overtime. If it's not, that's the easy part, right? If it's not, what do I get?
Less than 40.
Yeah, less than 40. So my pay is going to equal,
Pay.
pay equals what?
Our pay
Pay
rate
hours.
multiplied by
Our
number
pay
of hours.
rate times num hours. Okay, that's the easy part. Now I have to figure out how to calculate my overtime. If I work overtime, I need to be able to calculate that pay. So the top part of my if statement, if num hours is greater than 40, is now going to lead me into, I think, a couple of lines of code. So first thing I might want to do is figure out what my regular pay would be. How many hours would the regular pay be? Well, that's my first 40, right?
Yeah.
Okay. So I'm going to make a new variable. I'm going to say reg pay equals 40 times our pay rate. Sound good?
Question.
Yep.
Couldn't you just, because they're going to enter their hours worked, couldn't you just do hours worked and subtract 40? And then whatever's left over, you multiply that by what, time and a half?
So that's where we are now. So what I've done, I mean, there's multiple ways to do this. I'm just doing the regular pay, the overtime pay, and then what the total pay would be. So I have regular pay, I have OT pay, and I'm going to have to figure out what that is. And then I have my regular pay is going to be, or my pay is going to be reg pay plus OT pay. So what my reg pay is going to be the first 40 hours. My OT pay is what I'm going to make for overtime. And then my pay is going to be the regular pay plus the OT pay. Now, how do I figure out overtime pay? Well, if I worked 45 hours, how many hours are overtime?
5.
5. How'd you get that 5?
Subtract the 40 from 5, or 45,
Right.
I mean.
Right, so I'm going to take num hours and subtract 40. And then what am I going to do with those hours?
Multiply them by 1.5.
Multiply it by 1.5 and multiply it by,
Pay rate.
yeah, the hour pay rate. The hour pay rate. And some of you have other algebraic ways to do that, but early on in beginning programming, it needs to be broken down so everybody can get it. You know, the regular pay is the first 40 hours. The overtime pay is the number of hours minus 40 times 1.5 times hour pay rate. And then my pay, which is going to come out to be the regular pay plus the overtime pay. All right, so I inputted some things. I'm now going to output. I'm going to output what my pay rate was. I'm going to output my num hours because that's this is called echo printing your input. I want to make sure everything's on the screen so the user can see what's going on. And I want to finally print out pay because in both parts of the condition, in the if, the pay was and the pay was what I get for totaled out. Awesome sauce. Now,
Yep.
I'm not done yet. I want to do some algebra because when I run this, I don't want to get an answer and go woohoo and move on. I want to make sure it works. So I need some test data. So the first thing is our pay rate. I want to get some good test data here. Num hours and pay. Okay, what would you, give me an hourly pay rate. And remember, you're going to be doing the algebra here in your head quickly. So make it something that's kind of easy, like
10.
10. Give me the number of hours.
50.
Okay, so you jumped right in with the overtime. All right, and what should that be? Well, you guys are the algebra people, right? You have to have at least an algebra, college algebra background. What should my pay be?
500.
How much?
500.
500.
I have two 500s. So everybody agrees with 500.
No, it's 550.
Well, I'd rather get 550.
Mm.
I'm going to do some scratch work. For the first 40 hours,
Oh,
right,
that's
I get $400. And then there's 10 hours of overtime. So that's at 10 times 15 an hour. So that's 150. Yeah, I want to get 550 for my answer. Yeah. Another line of test data, 10. Let's do number of hours is 40. And let's make sure this is 400 hours. What's minimum wage?
I think it's 7.25. I think.
Depends what state you're in.
Yeah.
Okay. So all of a sudden, why did I just say, what is the hourly rate? What is minimum pay? Because what type of number do I have here? A double,
Double.
right? Yeah. So when I'm
Or a float.
working with money, we probably should be working with doubles. So if I did 725 for 10 hours, I should get $70.25. So now I feel pretty good about all of my notes and everything. Now I just need to type up the program, try my test data, and everything should be hunky-dory. All right, so I'm going to put you in groups of 3, and here's what I want you to do. I want you to first write a program, calculate the pay, including the overtime. Should be a piece of cake because we just wrote it. You may have to grab your books if you haven't typed in any if-else statements, just to be sure of the syntax. The second one I want you to write is ask the user to input a number, an integer, and then display is it odd or even. Sounds kind of easy, but I want to make sure you all know how to figure out if a number's odd or even, because we're going to see that in other programs. Then finally, the third one I want you to do is I want you to go back to your quadratic program, and I want you to check if the discriminant is greater than 0, we can keep working with our program. But if the discriminant is less than 0, what should we display? Well, my roots are going to, in fact, be imaginary. Remember, that's where the square root of -1, the whole I thing comes in. So just modify that quickly to say if the quadratic, after you calculate it, is greater than 0, then display your roots will be imaginary. Otherwise, display what your 2 roots would be. So we keep coming back to quadratic and we keep modifying it. And we're going to do that several more times. All right, so I have 20 students. I'm going to put you in groups of about 3. What's that? It makes 2 groups of 4. So I'm going to make 6 groups. And these are the 3 programs. Now, does anybody need this algorithm and test data we wrote? If you do, take your phone and take a picture of the screen real quick.
Yeah, I can't do that.
Yeah, no. You could, it wouldn't do you any good though.
Well, yeah, you're right.
Or do a print screen so that you have it. Because now that we see what we have, it should be a piece of cake. All right, and then the 3 programs. Go and get that overtime pay when working with. Go and get odd and even, and then go and modify your quadratic program. Now, if I put you in a group of 3, I don't want Joe to do number 1, Bob to do number 2, and Sal to do number 3, and then we'll just share with each other. Work on them. The collaboration is where you really benefit. You know, this whole positive group active learning will pay off in the long run. Questions?